There's something humbling and utterly thrilling about realizing just how little we truly understand about the universe. Picture this: a star that flickers in ways no known physics can explain, or a galaxy spinning in the wrong direction, defying every model astronomers have ever built. These aren't plot twists from a sci-fi novel. They're real cosmic anomalies, documented by telescopes and studied by baffled scientists. And the deeper we look, the more we find that the universe loves to break its own rules. It's as if the cosmos is whispering a challenge. Go ahead, try to figure me out. What makes these mysteries so captivating isn't just their strangeness, it's what they reveal about the limits of human knowledge. For centuries, we've mapped the heavens, crafted equations to predict celestial motions, and built theories to explain the birth of galaxies. Yet time and again, the universe throws us a curveball, forcing us to rethink everything we thought was certain. Take black holes, for instance. We've long accepted that nothing escapes their gravitational grip until we stumbled upon one that's spewing matter like a cosmic fountain. How? No one knows for sure, and that's just the beginning. This video is your ticket to the front row of cosmic discovery, where the impossible becomes routine. We'll journey through 22 of the most jaw-dropping anomalies ever recorded, phenomena that shouldn't exist but do, each one a puzzle begging to be solved. Some will make you question reality, others might keep you up at night, staring at the stars with newfound wonder. Whether you're a seasoned space enthusiast or just someone who loves a good mystery, prepare to have your mind stretched in ways you never expected. The universe is far stranger, far more unpredictable than we ever dared to imagine. Ready to dive in? Let's go. Imagine being pulled towards something you can't see, something so powerful it bends the motion of entire galaxies, yet remains hidden in plain sight. That's the eerie reality of the Great Attractor, a cosmic mystery lurking behind the thick curtain of stars and dust in our own Milky Way. For decades, astronomers have watched galaxies, including our own, racing toward this invisible point at mind-boggling speeds, as if caught in a river no one can map. The force behind this motion is strong enough to warp the paths of millions of galaxies across hundreds of millions of light years. Yet, despite its colossal influence, we still don't know exactly what it is. One leading theory suggests the Great Attractor might be a supercluster, an enormous gathering of galaxies with gravity so intense it pulls everything in its vicinity. But here's the twist: even the combined mass of those galaxies doesn't fully explain the strength of this cosmic tug. That's led scientists to suspect something far more exotic might be at play, perhaps a concentration of dark matter so dense it defies our current models, or even a structure we haven't yet imagined. The more we study it, the more the Great Attractor feels like a cosmic illusion, hiding its true nature just beyond our reach. What makes this anomaly so tantalizing isn't just its mystery, it's the way it challenges our entire understanding of how the universe organizes itself. If the Great Attractor is a supercluster, why does its gravity seem stronger than it should be? And if it's something else entirely, what does that mean for the laws of physics we've relied on for centuries? Every observation deepens the puzzle, leaving us with more questions than answers. One thing's certain: until we peer behind the Milky Way's veil, the Great Attractor will remain one of space's most compelling enigmas, a reminder that even in an age of advanced telescopes, the universe still holds secrets we've barely begun to uncover. Now picture an entire river of galaxies, thousands of them, being swept toward some unseen destination at nearly 2 million miles per hour. This isn't science fiction. It's the bizarre reality of dark flow, one of the most unsettling cosmic mysteries ever discovered. In the early 2000s, astronomers noticed something impossible. Clusters of galaxies far beyond our local supercluster weren't just drifting randomly through space. They were all racing in the same direction, as if pulled by some invisible hand. The strangest part, the source of this motion lies outside the observable universe, in a place we can't see, measure, or even comprehend. One explanation points to the aftermath of the Big Bang itself. Some theorists suggest dark flow could be the lingering tug of massive structures born in the universe's earliest moments, regions so dense their gravity still influences galaxies billions of years later. Others dare to propose something even wilder, that this motion is evidence of neighboring universes beyond our own, their gravitational pull leaking into our cosmic neighborhood like whispers through a wall. If true, it would mean our universe isn't just expanding, it's being dragged towards something unimaginably vast, something we may never fully understand. But here's where things get really puzzling. The standard model of cosmology insists this shouldn't be happening. On large scales, the universe is supposed to be uniform, with galaxies moving apart in all directions as space itself expands. Dark flow shatters that assumption, revealing a cosmos that's far less predictable than we thought. Could it be a flaw in our theories? A sign of undiscovered physics? Or is the universe simply reminding us that its deepest secrets are still hiding in plain sight? Every new observation adds another layer to the mystery, leaving scientists to wonder. If galaxies are being pulled towards something beyond the edge of reality, what else is out there that we can't see? The universe is unimaginably vast, with billions of galaxies, each containing billions of stars, and yet, we've never heard so much as a cosmic whisper from another civilization. This deafening silence is the heart of the Fermi Paradox, a puzzle that's haunted scientists for decades. If the conditions for life are so common, where is everyone? The numbers suggest the cosmos should be buzzing with activity. Even if intelligent life is rare, the sheer scale of existence means we shouldn't be alone. And yet, every radio telescope trained on the stars hears only static. One chilling possibility is that civilizations simply don't last long enough to be found. Imagine a species reaching the technological peak needed for interstellar communication only to collapse under war, environmental disaster, or some unseen cosmic threat. It's as if the universe is littered with graveyards of societies that burn too brightly, too briefly. Others propose that advanced civilizations might deliberately avoid contact, hiding in the cosmic shadows like hunters wary of revealing their position. Or perhaps we're searching the wrong way, like trying to spot a flashlight in a thunderstorm, missing signals that operate beyond our current understanding of physics. But the most unsettling answer of all, we might truly be the first. The universe is ancient, but the conditions for complex life could be vanishingly rare, or require such precise timing that we're the earliest ones to emerge. If that's true, the silence isn't just mysterious, it's profound. It means the responsibility of shaping the cosmos's future rests entirely on us. Every star, every planet, every uncharted frontier might one day echo with the choices humanity makes. The Fermi Paradox doesn't just ask where the aliens are, it forces us to confront what it means if we're the only voices in the dark. Some stars flicker gently, like candles in a cosmic breeze. But then there's Tabby's star, a sun that doesn't just dim. It plummets in brightness, sometimes by as much as 22%, as if something colossal is passing in front of it. And unlike regular stars which dim in predictable patterns, this one does it erratically with no rhythm at all. When astronomers first spotted this bizarre behavior, they were stunned. Nothing in nature should block that much light so unevenly unless, of course, it wasn't natural at all. For a while, the most tantalizing theory was that we might be looking at an alien megastructure, a hypothetical swarm of energy-collecting satellites called a Dyson sphere, built by an advanced civilization to harness their star's power. The idea sent ripples through the scientific community. After all, what else could explain such drastic, irregular dimming? But as more data rolled in, a simpler culprit emerged: dust. Not ordinary dust, though. This was a strange, uneven cloud of fine particles, possibly from shattered comets or a chaotic debris field, drifting in clumps around the star. It's a natural explanation, but one that raises its own questions. Why is there so much dust, and why does it behave so unpredictably? What makes Tabby's star so fascinating isn't just the mystery, it's the way it forces us to confront the limits of our imagination. Even as evidence points toward natural causes, the star's wild fluctuations keep the door cracked open for something extraordinary. Maybe it's a phenomenon we've never seen before, a new kind of cosmic weather, or the aftermath of a planetary collision. Or perhaps, just perhaps, it's a sign that the universe is even stranger than we've dared to dream. Every flicker of this enigmatic star is a reminder. Sometimes the most thrilling discoveries aren't the answers we find, but the questions we can't yet solve. On a quiet August night in 1977, a radio telescope in Ohio picked up something extraordinary, a burst of sound so powerful, so unnatural, that the astronomer who discovered it scribbled, "Wow," in red ink right on the data printout. That single 72-second signal, blaring from the constellation Sagittarius, remains one of the most tantalizing cosmic mysteries ever recorded. It wasn't static or interference. It wasn't a known celestial phenomenon. It was a narrowband radio wave, the exact frequency scientists had predicted an alien civilization might use to communicate. And then, just like that, it vanished, never to be heard again. The WOW signal's sudden appearance and disappearance have fueled debates for decades. Natural explanations range from a passing comet's hydrogen cloud to an exotic astrophysical event we've yet to understand. But here's the catch. No comet was recorded in that region of space at the time, and no known cosmic object behaves this way. The signal's intensity spiked and fell in a pattern eerily similar to what we'd expect if a distant transmitter swept briefly across Earth's field of view. It's as if the universe handed us a message in a bottle, then snatched it away before we could read it. What makes this anomaly so haunting isn't just its mystery, but its timing. The WOW signal arrived during humanity's first serious effort to listen for extraterrestrial intelligence, almost as if the cosmos was testing our readiness. Had we missed a reply window? Was it a one-time beacon or part of a transmission we lacked the technology to fully receive? Even today, with telescopes far more advanced, we've found nothing like it. The signal lingers like a cosmic riddle, challenging us to reconsider what's possible. Maybe it was a fluke, a freak alignment of natural forces. Or maybe, just maybe, it was the first whisper of a conversation we weren't yet equipped to continue. Either way, it stands as a humbling reminder. The universe is full of voices. We're still learning how to hear them. Out in the depths of space, where telescopes reveal galaxies packed together like glitter spilled across black velvet, there's a place that defies all expectations, a yawning chasm so empty, so unnervingly blank, it's earned the nickname the Great Nothing. The Boötes Void stretches an astonishing 330 million light-years across, a region so vast it could swallow thousands of galaxies whole. Yet when astronomers peer into it, they find almost nothing. No spiraling star systems, no glowing clusters, just a haunting, near-total absence of matter. It's as if someone took an eraser to the cosmos, scrubbing away everything in its path. This isn't just unusual, it's impossible by our current understanding of the universe. According to the standard model of cosmology, matter should be distributed relatively evenly across large scales, with galaxies strung along filaments of dark matter like beads on a cosmic web. The Boötes Void shatters that assumption. Imagine walking into a forest where suddenly you stumble upon a clearing the size of a continent, not just empty, but devoid of any trees, bushes, or even roots beneath the soil. That's the scale of this mystery. So what could carve such a void? One theory suggests it's the aftermath of an ancient collision between bubbles of space-time in the early universe, a catastrophic event that left behind a scar of nothingness. Others propose it's not truly empty, just hiding galaxies too faint or spread out for our telescopes to detect. But even then, the numbers don't add up. The few galaxies found within the void are oddly isolated, like lone survivors in a wasteland, drifting far from the bustling cosmic neighborhoods they should belong to. Perhaps the most unsettling possibility is that the void isn't a flaw in our models, but a clue to something deeper. Could it be evidence of exotic physics, a region where dark energy behaves differently, pushing matter apart with unnatural force? Or is it a sign of structures so vast, so alien, that we're only seeing the shadow they cast on the universe? Every observation deepens the enigma, leaving scientists to grapple with a truth as stark as the void itself. Sometimes the most profound mysteries aren't about what's out there, but about what isn't. One moment, space is silent. The next, an explosion of radio waves bursts across the cosmos with the power of 500 suns, then vanishes without a trace. These are fast radio bursts, some of the most energetic and perplexing signals ever detected. Lasting just milliseconds, they travel billions of light years to reach us, carrying energy equivalent to what our sun emits in 80 years. And while most appear as one-off events, a handful repeat in patterns so strange, they've left scientists scrambling for explanations. Take FRB 12-1102, the first repeating fast radio burst ever discovered. Unlike its fleeting cousins, this one fires off signals like clockwork, cycling through active and silent periods every 157 days. It's as if some cosmic lighthouse is flickering on a schedule we're only beginning to decode. The leading theory points to highly magnetized neutron stars called magnetars, whose violent starquakes might unleash these colossal energy surges. But here's the catch. Even the most powerful magnetar eruptions can't fully account for the sheer intensity of some FRBs, especially those repeating with unnatural precision. That's where things get really intriguing. Could these bursts be the byproduct of advanced technology? Some researchers have floated the idea of alien light sails, propelled across galaxies by planet-sized transmitters firing concentrated energy beams. Each time the beam sweeps past Earth, we'd catch a fleeting, ultra-powerful pulse. It's a far-out hypothesis, but one that underscores just how baffling these signals are. After all, when natural explanations fall short, the universe invites us to consider possibilities beyond our current understanding. What makes FRBs so captivating isn't just their mystery, it's what they reveal about the cosmos' hidden chaos. These bursts distort as they travel, bending through clouds of ionized gas that might hold clues to the universe's missing matter. Some even arrive with a bizarre twist, their radio waves polarized in spirals, suggesting they've passed through incredibly strong magnetic fields. Each detection is like intercepting a cosmic telegram, stamped with secrets about the space it's traversed. Yet for every answer, a dozen new questions emerge. Why do some FRBs repeat while others don't? What could generate such precise patterns across unimaginable distances? And if they are natural, what catastrophic astrophysical events are we still blind to? With every new burst captured, astronomers edge closer to unraveling the puzzle, or stumbling upon something even more extraordinary. One thing's certain, in a universe teeming with radio whispers, these fleeting screams demand to be heard. Black holes are cosmic paradoxes incarnate, regions where gravity is so intense that not even light can escape. But here's the twist: what happens to the information of everything that falls in? According to Einstein's general relativity, black holes should obliterate information entirely, leaving no trace of the stars, planets, or gas they've swallowed. Yet quantum mechanics insists that information can never truly be destroyed. This clash isn't just academic, it's a battle for the soul of physics, forcing scientists to question whether our deepest theories about reality are fundamentally incomplete. The problem became impossible to ignore when Stephen Hawking revealed that black holes aren't entirely black. They emit faint radiation, now called Hawking radiation, slowly evaporating over eons. But here's the catch: that radiation appears random, carrying no data about what the black hole consumed. If the hole eventually vanishes, leaving only this thermal static behind, where did the original information go? Imagine burning a book and claiming its contents still exist because you've saved the ashes. The words are gone, even if the particles remain. That's the crisis at the heart of the information paradox. Some theorists argue the information isn't lost, just scrambled beyond recognition, like a cosmic shredder turning secrets into quantum gibberish. Others propose wilder solutions, like holographic universes where data isn't stored inside the black hole but smeared across its event horizon, a two-dimensional surface encoding three-dimensional truth. Then there's the radical idea of firewalls, searing walls of energy at the event horizon that destroy information before it even enters, violating relativity's prediction that falling into a black hole would feel uneventful at least until gravity's tidal forces took over. What makes this paradox so electrifying isn't just the intellectual tug-of-war, it's the stakes. If information can vanish, quantum mechanics collapses. If it can't, Einstein's relativity might need rewriting. Every proposed solution unravels another thread in our understanding, exposing gaps we never knew existed. And lurking beneath it all is a haunting question. If black holes, the universe's simplest objects, defy our best theories, what else have we gotten wrong? This isn't just about missing data. It's about whether the cosmos operates by rules we're even capable of comprehending. Perhaps the most humbling realization is that black holes aren't the villains here. They're merely exposing the limits of human knowledge, revealing where our equations fracture under extreme conditions. Until we reconcile relativity with quantum mechanics, or discover a deeper framework that unites them, the paradox stands as a monument to our ignorance. It's a cosmic riddle whispered across event horizons, daring us to look deeper. And one day, when the answer comes, it might not just solve a puzzle, it could rewrite reality itself. Some mysteries don't announce themselves with flashes of light or bursts of radio waves. They creep in silently, like shadows stretching across the fabric of physics itself. That's exactly what happened with the Pioneer Anomaly, a decades-long puzzle involving two of NASA's most reliable spacecraft. Launched in the 1970s, Pioneer 10 and 11 were workhorses of deep space exploration, charting paths past Jupiter and Saturn before venturing toward the edge of our solar system. But as they drifted farther from Earth, something bizarre occurred. Both probes began slowing down ever so slightly, as if an unseen hand was tugging them backward. At first, the deviation was minuscule, just 300 billionths of a meter per second squared. But over years, that tiny discrepancy added up, pushing the Pioneers thousands of miles off their predicted trajectories. The strangest part, no known force could explain it. Newton's laws, which had governed orbital mechanics for centuries, insisted the probe should coast smoothly unless acted upon. Yet here they were, defying expectations with no clear culprit. For a while, scientists flirted with radical explanations. Was there an undiscovered planet lurking in the outer solar system, its gravity nudging the probes? Could dark matter be clustering near us, bending motion in ways we couldn't detect? Or most thrilling of all, was this a sign that gravity itself behaved differently at extreme distances? The answer, when it finally came, was both mundane and brilliant. After years of painstaking analysis, researchers realized the anomaly wasn't caused by hidden forces or new physics, it was heat. The Pioneer's radioactive power sources emitted tiny amounts of thermal radiation, and as those photons bounced off the spacecraft's asymmetrical surfaces, they created a minuscule but consistent push, like a gentle breeze against a sail. It was a masterclass in how even the subtlest details can ripple into measurable effects across cosmic distances. Yet the Pioneer Anomaly's legacy lingers, not as a closed case, but as a cautionary tale. It reminds us how easily the universe can masquerade the ordinary as extraordinary, and how often the answers we seek are hiding in plain sight. But it also raises a tantalizing question. If something as simple as heat could mimic the signature of unknown physics, what other anomalies might we be misreading? The solar system is vast and our models are imperfect. Somewhere out there, another puzzle might be waiting, one that doesn't have a textbook explanation. The pioneers taught us to look closer before leaping to conclusions, but they also left us wondering, what if next time the anomaly isn't so easily solved? The universe is supposed to be uniform, no special directions, no preferred corners, no cosmic up or down. That's the principle of isotropy, a foundational idea in cosmology. But in 2003, scientists studying the afterglow of the Big Bang stumbled upon something that shouldn't exist. A mysterious axis running through the cosmos, nicknamed the axis of evil. This bizarre alignment in the cosmic microwave background, the oldest light in the universe, reveals hot and cold spots that aren't randomly scattered as expected. Instead, they're subtly arranged along a line, as if the universe itself has a tilt. What makes this discovery so unsettling is what it implies. If the cosmos has a preferred direction, it challenges the very assumption that the universe looks the same no matter where you're standing. Imagine spinning a globe and realizing it always tilts toward one continent, no matter how you hold it. That's the level of weirdness we're dealing with here. Some researchers argue this could be evidence of an ancient gravitational wave so colossal it warped space-time on a universal scale. Others speculate it might hint at a structure outside our observable universe, something so vast its gravity still tugs at the fabric of reality. Then there's the most radical possibility, that the axis isn't a physical feature at all, but a flaw in our understanding of physics itself. Could Einstein's relativity need tweaking at cosmic scales? Is dark energy interacting with matter in ways we haven't accounted for? Every attempt to explain the anomaly either falls short or opens doors to even bigger questions. Even the name Axis of Evil reflects the frustration. It's a darkly humorous nod to how stubbornly this mystery resists tidy solutions. The real intrigue lies in what this means for our place in the cosmos. If the universe does have a preferred direction, are we somehow aligned with it by chance? Or is there something special about our vantage point? It's a humbling thought. After centuries of insisting we occupy no privileged position in space, we might be staring at evidence that the universe does play favorites. The axis of evil doesn't just defy models, it forces us to confront how much we still don't know about the grand stage we call home. And until we crack its code, it stands as a silent reminder. the universe may be far more structured, far more ordered than we ever imagined. We think we know what the universe is made of: protons, neutrons, electrons, the building blocks of everything we see. But here's the cosmic twist: half of that normal matter, the stuff that should be there, is missing. Not dark matter, not exotic particles, just ordinary atoms that have somehow slipped through our observational nets. This is the missing Baryon problem, a puzzle so persistent it's made scientists question whether we've been searching in the wrong places all along. For decades, astronomers tallied up the universe's visible matter, stars, galaxies, gas clouds, and compared it to predictions from the Big Bang. The numbers didn't just disagree, they were wildly off. Where was the other 50%? The answer, it turns out, might be hiding in plain sight, woven into the fabric of the cosmos itself. Recent studies point to vast, diffuse filaments of superheated gas stretching between galaxies, a cosmic web too faint to see with traditional telescopes. These threads, hotter than the sun's core and thinner than the void between stars, could be the universe's ultimate hiding spot. Detecting this phantom matter isn't easy. The gas is so hot it emits X-rays, but so sparse that its signal drowns in cosmic noise. It's like trying to spot a single lit match from 1,000 miles away. Yet clever techniques, like studying how distant quasars' light dims as it passes through these filaments, are starting to reveal whispers of this hidden network. And the implications are staggering. If these filaments are real, they don't just solve a math problem, they explain how galaxies grow. Picture this: galaxies aren't isolated islands, but nodes in a grand arterial system, fed by rivers of invisible matter flowing along these threads. But the mystery isn't fully solved. Even with these discoveries, some baryons remain stubbornly unaccounted for. Could they be lurking in even hotter, more elusive regions? Or might they exist in forms we haven't yet imagined, perhaps condensed into rogue planets drifting between stars, or locked inside black holes' event horizons? Every new observation chips away at the enigma, but the universe guards its secrets well. What's certain is this: the missing matter isn't just a gap in our data. It's a clue to how the cosmos stitches itself together, one invisible thread at a time. And until we find it all, we're left with a humbling truth: even the ordinary can become extraordinary when the universe decides to hide it. Deep in the constellation Monoceros, about 2,300 light-years from Earth, a dying star is performing one of the universe's most baffling encores. Known as the Red Rectangle Nebula, this cosmic spectacle shouldn't exist, at least not in the shape we see it. Most planetary nebulae, the glowing shells of gas expelled by aging stars, form intricate but chaotic patterned spirals, bubbles, or jagged tendrils. But this one, it's a near-perfect X inscribed inside a rectangle, with ladder-like rungs of glowing material stretching between its walls. The geometry is so precise, so unnervingly symmetrical. It looks less like a stellar death throes and more like an architectural blueprint. The mystery begins with the star at the nebula's heart, HD 44179. As it sheds its outer layers, the expelled gas should ripple outward in all directions, creating the usual irregular clouds. Instead, something, perhaps an unseen companion star or a dense disk of dust, is sculpting the outflow into these razor-sharp angles. The leading theory suggests twin jets of material, ejected perpendicular to the star's rotation, are carving the X shape, while a thick dust torus around the star's equator confines the glow into rectangular bands. But even this explanation feels incomplete. Why are the rungs so evenly spaced? Why does the structure hold its form across light years without blurring? It's as if the universe drafted this nebula with a ruler and protractor. What makes the red rectangle so mesmerizing isn't just its shape, it's the way it challenges our assumptions about chaos and order in space. We're used to thinking of cosmic phenomena as messy, governed by turbulence and chance. Yet here's an object that defies that expectation, offering a glimpse of hidden symmetries lurking in nature's toolbox. Some researchers speculate that magnetic fields, far stronger than predicted, might be orchestrating this precision. Others wonder if we're witnessing a rare phase of stellar evolution, one where physics conspires to create temporary perfection before the nebula dissolves into the interstellar void. Then there's the color, that eerie, blood-red hue. Unlike most nebulae, which glow in blues and greens from ionized oxygen, the red rectangle's light comes from a bizarre class of molecules called polycyclic aromatic hydrocarbons. These complex carbon-based compounds, often found in soot or engine exhaust on Earth, shouldn't survive the harsh radiation of a dying star. Their presence hints at chemistry we've barely begun to unravel, a reminder that the cosmos cooks up substances far stranger than anything in our textbooks. Perhaps the most tantalizing question isn't how the red rectangle formed, but why we don't see more like it. Is this nebula a cosmic fluke, a fleeting alignment of conditions that's vanishingly rare? Or are we simply missing others like it, their geometries hidden by distance or orientation? Every new observation peels back another layer, revealing not just answers but deeper mysteries. The red rectangle doesn't just defy explanation, it invites us to rethink what's possible when a star breathes its last. In its sharp angles and glowing rungs, we're seeing more than a celestial oddity. We're seeing the universe's capacity for artistry, written in light and gas. Beyond the orbit of Neptune, where sunlight is 1,000 times dimmer than on Earth, the Kuiper belt stretches like a frozen junkyard of cosmic leftovers, icy rocks, dwarf planets, and fragments from the solar system's birth. But something bizarre happens around 4.8 billion miles out. The belt doesn't fade gradually into emptiness. It plummets. This sudden absence of objects, known as the Kuiper Cliff, is as jarring as walking through a dense forest only to hit an open plain with no trees in sight. The drop-off is so sharp, so statistically unlikely, it's as if some unseen force swept the region clean. One tantalizing explanation points to Planet 9, a hypothetical world up to 10 times the mass of Earth, lurking in the darkness beyond our telescope's reach. Its gravity could have shepherded distant Kuiper belt objects into clustered orbits while ejecting others entirely, leaving behind this eerie boundary. The math supports the idea. Simulations show a massive, distant planet could explain not just the cliff, but also the strange, tilted orbits of some far-flung objects like Sedna. Yet after years of searching, no such world has materialized. Is it hiding in plain sight, camouflaged by the vastness of space? Or are we chasing a ghost, misreading the cosmic tea leaves? But Planet 9 isn't the only suspect. Another theory suggests the cliff might be a scar from the solar system's violent youth, a relic of a close encounter with a passing star. Imagine another sun grazing our outer edges billions of years ago, its gravity plucking away icy bodies like a thief in the night. If true, the Kuiper Cliff wouldn't just mark a boundary, it would be a fossilized record of interstellar theft. Then there's the wild card. What if the cliff isn't caused by a single event, but by something far stranger? Some researchers speculate that the early solar system's protoplanetary disk might have had an inherent edge, a natural cutoff where materials simply didn't accumulate. Or perhaps the objects beyond the cliff are so dark, so devoid of reflective ice that our telescopes can't spot them yet. The Kuiper Cliff isn't just a curiosity, it's a frontier. Every unanswered question forces us to confront how little we know about our own cosmic backyard. If a planet is out there, its discovery would rewrite astronomy textbooks. If it's not, the cliff becomes a puzzle begging for new physics. one thing's certain: the edge of the solar system isn't the quiet, orderly place we once imagined. It's a dynamic, chaotic zone where the rules are still being written, and the Kuiper Cliff is its most enigmatic punctuation mark. Galaxies are supposed to shine brimming with stars, dust, and glowing gas. But in 2016, astronomers stumbled upon something that defies that expectation. Dragonfly 44, a galaxy so faint it's practically invisible, yet with the mass of a Milky Way. Here's the catch: 99.99% of that mass isn't stars or gas. It's dark matter, an invisible scaffold holding the galaxy together like a ghostly skeleton. This isn't just a curiosity, it's a cosmic revolution hiding in plain sight, forcing us to ask, how do you even build a galaxy without the ingredients we thought were essential? Dragonfly 44 wasn't found by spotting its light. Instead, researchers noticed stars within it moving far too fast for the galaxy's visible matter to hold them in orbit. The only explanation: an enormous halo of dark matter, its gravity acting like an invisible hand keeping everything from flying apart. Imagine a carousel spinning so fast its horses should be flung into the sky, yet they aren't because unseen chains tether them down. That's the eerie reality of this dark galaxy. What makes Dragonfly 44 so unsettling isn't just its existence, it's what it implies about the universe's hidden architecture. Standard galaxy formation theory says dark matter acts as a gravitational seed, pulling in gas that eventually ignites into stars. But here's a galaxy where that process stalled almost entirely, leaving behind a shadowy colossus with barely any stellar fireworks. Could this mean dark matter isn't always the efficient star maker we assumed? Or is Dragonfly 44 a fossil from an earlier cosmic era, a relic of a time when dark matter clumped differently? The implications ripple outward. If this galaxy isn't alone, and there's every reason to think it isn't, we might be surrounded by invisible giants, their presence betrayed only by the subtle tug they exert on nearby objects. Some researchers estimate there could be thousands of these dark galaxies for every Milky Way-like system, lurking unseen like a parallel universe woven into our own. The problem: finding them is like searching for footprints in a pitch-black room. Without stars to light the way, these ghosts reveal themselves only through painstaking observations of gravitational side effects, a starfield subtly warped here, a cluster of stars moving suspiciously fast there. Yet the most tantalizing question isn't how many dark galaxies exist, it's why they exist at all. Are they failed experiments in cosmic evolution, places where star formation fizzled out? Or could they be the rule rather than the exception, with our bright, star-filled galaxies being the odd ones out? Every new detection peels back another layer of this mystery, revealing a universe far stranger than the one we thought we knew. Dragonfly 44 isn't just an anomaly. It's a window into the invisible forces shaping everything we see, and a humbling reminder that most of the cosmos might be hiding in the dark. Our moon is a cosmic oddity in plain sight, a silent companion that shouldn't exist as it does. Compared to other moons in the solar system, Earth is bizarrely oversized, a quarter the diameter of its host planet. Most moons are tiny captives, grabbed by gravity or leftover debris from their planet's formation. But ours, it's more like a sibling born from chaos. The leading theory, the giant impact hypothesis, paints a dramatic origin story. 4.5 billion years ago, a Mars-sized object named Theia smashed into a young, molten Earth, vaporizing rock and flinging debris into orbit. Over time, that debris coalesced into the moon we know today, but this tidy explanation has cracks. For one, the moon's composition is eerily similar to Earth's mantle, too similar. If Theia was a foreign body, its remnants should leave distinct chemical fingerprints. Yet moon rocks show almost no trace of Theia's hypothetical material, as if the collision blended everything perfectly. Some scientists suggest Theia might have been a cosmic doppelganger, formed in the same orbit as Earth, making its composition nearly identical. Others propose the impact was so violent it vaporized both worlds entirely, creating a swirling mix that later reformed as Earth and its moon. Then there's the moon's orbit tilted just 5 degrees from Earth's equator, far less than most moons, which often orbit at wild angles. This near-perfect alignment hints at a gravitational dance that's been fine-tuned over eons. But how? One provocative idea is that the moon once had a twin, a smaller companion that stabilized its early orbit before vanishing. Simulations show a second moon could have spiraled into our current one, explaining the oddly smooth far side and the rugged, mountainous near side. The crash might have left its mark in the moon's lopsided crust, a silent echo of a lost sibling, and the anomalies don't stop there. For centuries, observers have reported transient lunar phenomena, fleeting flashes of light, glowing mists, or patches of color that appear and vanish on the moon's surface. These aren't just tricks of the eye. Modern telescopes and lunar orbiters have documented them too. Some flashes could be meteorite impacts or solar flares reflecting off lunar dust. But others defy easy explanation, sparking speculation about outgassing from trapped volatiles or even electrostatic discharges in the moon's tenuous exosphere. What makes the moon so endlessly fascinating isn't just its mysteries, it's how they force us to rethink planetary science. If the moon's birth was more violent or complex than we assumed, what does that mean for other worlds? Could binary moons be common in the universe, their remnants hidden in the scars of distant craters? And if the moon still holds active processes beneath its dead exterior, what other surprises lurk in plain sight? Every rock brought back, every orbit mapped, peels back another layer of this celestial riddle. The moon isn't just our nearest neighbor, it's a time capsule, a puzzle, and a reminder that even the most familiar objects in the night sky can hold secrets waiting to be uncovered. There's a structure in the cosmos so vast it redefines the word large, the hercules-corona Borealis Great Wall, a staggering filament of galaxies stretching an almost incomprehensible 10 billion light-years across. To put that in perspective, if you could travel at light speed, a brisk 670 million miles per hour, it would take you longer to cross this single structure than the current age of our entire universe. And here's the real kicker: this cosmic leviathan shouldn't exist at all. According to our best models of the early universe, there's a fundamental limit to how big things should be able to get. Known as the cosmological principle, it states that on the largest scales, matter should be distributed evenly. No gargantuan structures, no preferred directions, just a smooth cosmic soup. Yet the Great Wall shatters that assumption like a hammer through glass. Imagine finding a single tree stretching halfway around the planet. That's the scale of violation we're talking about. Even stranger, this structure emerged shockingly early, just 2 billion years after the Big Bang, a time when the universe was far too young for gravity to have sculpted something so immense. So how did it form? One radical idea suggests the Great Wall might be a fossilized imprint of quantum fluctuations from the universe's first moments, tiny ripples in space-time that, against all odds, ballooned into a cosmic mountain range. Others speculate it's evidence of exotic physics, like dark energy behaving differently in the ancient cosmos, accelerating matter's clumping in ways we can't yet explain. Then there's the unsettling possibility that our wall isn't a single structure at all, but the shadow of something even grander, a network of superclusters woven together by forces we've yet to discover. What makes this anomaly so humbling isn't just its size, It's the way it forces us to confront the limits of our cosmic vision. The Great Wall lies right at the edge of our observable universe, a frontier where light from more distant regions hasn't had time to reach us. Could there be even larger structures lurking just beyond our view? And if so, what does that mean for the so-called principles we've built our cosmology upon? Every new survey deepens the mystery, revealing a universe far more textured, far more unruly than we ever predicted. The hercules-corona Borealis Great Wall isn't just a curiosity. It's a cosmic wake-up call, reminding us that the universe's rulebook might still have chapters we haven't even begun to read. Somewhere in the constellation Serpens, about 4,000 light-years from Earth, a world exists that would make any jeweler's heart skip a beat, a planet literally made of diamond. Officially named PSRJ 1719-1438b, but nicknamed the Diamond Planet, this celestial gemstone orbits a pulsar, the rapidly spinning corpse of a dead star. And here's the twist: this isn't just a planet with a diamond core or scattered crystals. Current models suggest it's mostly crystallized carbon, a cosmic chandelier glittering in the void. How does something so bizarre even form? The leading theory reads like a cosmic horror story. Once, this world was likely a massive star itself, locked in a binary dance with its pulsar companion. When the pulsar's predecessor went supernova, the blast stripped away the outer layers of its stellar neighbor, leaving behind a naked core of ultra-dense carbon. Under unimaginable pressure and heat, that carbon crystallized into diamond, not the delicate gemstones we know, but a structure spanning thousands of miles, harder than anything in our solar system. What makes this world so fascinating isn't just its composition, it's how it blurs the line between planet and star remnant. By traditional definitions, planets form from debris disks around young stars, not the corpses of dead ones. Yet here it is, defying categorization. Some astronomers argue it's more akin to a white dwarf that got shredded down to planetary size, while others insist it's proof that planet might need a broader definition in this wild universe. And the Diamond Planet isn't alone in its strangeness. Out there in the dark, we've found worlds that rain molten glass, planets with skies of vaporized rock, and even rogue planets drifting untethered from any star. Each discovery forces us to rethink what's possible. Could there be planets made of solid metal, forged in the heart of supernova, or worlds so rich in exotic elements they glow in colors we've never seen? The real lesson here isn't just about cosmic bling, it's about perspective. For centuries, we assumed other solar systems would resemble ours, but the universe keeps serving up worlds that look nothing like home, reminding us that nature's imagination dwarfs our own. The Diamond Planet isn't an anomaly, it's a preview. Every bizarre world we find cracks open the door to others we haven't yet dreamed of, waiting in the dark to surprise us. At the very edge of our galaxy, where the Milky Way's spiral arms fade into the void, there's an invisible wall not of rock or ice, but of pure energy. Astronomers call it the Galactic Barrier, and it behaves like no other structure in the cosmos. Cosmic rays, high-energy particles racing across the universe slam into this boundary as if hitting a force field, their paths abruptly bending or scattering. Some are even reflected back into the galaxy, like echoes of some unseen cosmic defense mechanism. What makes this barrier so perplexing isn't just its existence, it's the way it defies easy explanation. One theory suggests it's the result of the Milky Way's magnetic field, twisted and amplified at its outer edges into a kind of natural fence. But here's the problem. The barrier's strength and uniformity don't match what we'd expect from random magnetic turbulence. It's too organized, too consistent, as if something or someone has fine-tuned it. Then there's the timing. The barrier seems to have intensified over cosmic timescales, coinciding roughly with the rise of complex life on Earth. Is that just a fluke, or could there be a connection? Some speculative hypotheses dare to suggest the barrier might serve a purpose shielding the inner galaxy from high-energy particles that could disrupt star formation or even sterilize budding planets. It's a wild idea, but not impossible. After all, nature has a way of building protective structures, from Earth's ozone layer to the heliosphere that shelters our solar system. But the most tantalizing clue lies in what the barrier doesn't block. Certain neutrinos and gravitational waves pass through unimpeded, as if the barrier is selectively filtering what enters or leaves. This selectivity raises an eerie question. If it's just a natural phenomenon, why doesn't it affect everything equally? Could there be rules, boundaries written into the fabric of our galaxy that we're only now beginning to detect? Of course, skepticism remains. Many scientists argue the barrier is simply an emergent property of galactic dynamics, a side effect of how magnetic fields interact with dark matter halos. Yet even they admit the puzzle isn't fully solved. Every new observation adds another layer of mystery, revealing a galaxy far more structured and far more enigmatic than we ever imagined. The Galactic Barrier doesn't just challenge our understanding of astrophysics. It forces us to wonder whether the universe plays by rules we haven't even discovered yet. And until we peer beyond that invisible wall, its true nature will remain one of the Milky Way's most guarded secrets. Galaxies are supposed to follow certain rules. Spirals spin with elegant precision. Ellipticals glow with ancient starlight, and all of them, without exception, are thought to be held together by the invisible grip of dark matter. That's why the discovery of ultra-diffuse galaxies like NGC 1052 and DF2 sent shockwaves through astrophysics. These ghostly islands of stars drift through space almost see-through, their sparse collections of stars shining faintly against the cosmic dark. But the real bombshell, they're missing something fundamental, the dark matter that should account for 90% of their mass. It's like finding a skyscraper standing tall with no foundation, or a whirlpool spinning without water. The first clue something was off came when astronomers measured the motion of stars within these galaxies. Normally, stars orbit so fast that without the extra gravity from dark matter, they'd fly apart like a merry-go-round spun too quickly. But in these ultra-diffuse oddballs, the stars move sluggishly, exactly as they should if only visible matter were present. No hidden mass, no mysterious pull. Just stars drifting lazily in defiance of everything we thought we knew about how galaxies work. So how does a galaxy lose its dark matter? One leading theory suggests these wispy structures might be the battered remnants of violent cosmic encounters. Picture a normal galaxy, rich with dark matter, wandering too close to a massive cluster. The cluster's gravity could strip away the dark matter like a tide pulling sand from a beach, leaving behind only the stars, now unmoored from their invisible scaffold. Simulations show this tidal stripping might explain some cases, but here's the catch. Many of these dark matter-free galaxies float in isolation, far from any disruptive neighbors. If they weren't torn apart, how did they form this way? That's where things get even stranger. Some researchers propose these galaxies might have been born in a rare cosmic environment where dark matter was unusually scarce, perhaps a bubble in the early universe where matter clumped differently. Others wonder if dark matter isn't missing at all, but behaving in ways we can't yet detect. Could it be spread so thinly or interact so weakly that our instruments simply overlook it? What makes these galaxies so revolutionary isn't just their defiance of expectations, it's what they reveal about the diversity of cosmic structures. For decades, dark matter was the universal glue, the one ingredient no galaxy could do without. Now we're staring at proof that the universe has more than one recipe for building islands of stars. Some might be dark matter dominions, others fleeting stellar specters. And if that's true, it forces us to ask, how many more galactic oddballs are out there, hiding in plain sight, waiting to rewrite the rules we thought were set in stone? Stars aren't supposed to cheat death. When a massive sun reaches the end of its life, it's meant to go out in one final, spectacular blaze, a supernova so violent it can outshine entire galaxies. But in 2014, astronomers witnessed something that defied this cosmic rulebook. A star that exploded, then did it again and again and again. Meet IPTF-14 HLS, the so-called zombie star, a celestial anomaly that refuses to stay dead, erupting in repeated supernova like a cosmic jack-in-the-box. The first explosion was dramatic but unremarkable, a typical Type II supernova, the kind caused by a collapsing stellar core. But 600 days later, when the star should have faded into oblivion, it suddenly brightened instead, as if someone had poured gasoline on dying embers. Then it happened a third time and a fourth. Each outburst defied physics as we know it, because supernovae aren't just fireworks, they're the universe's most destructive events. A star that survives one is impossible. A star that repeats them, that's not just impossible, it's rewriting the textbooks. So what's keeping this stellar phoenix alive? One leading theory suggests the zombie star might be part of a binary system, locked in a deadly dance with a companion. As the dying star sheds its outer layers, its neighbor could be siphoning off material, periodically dumping it back onto the corpse in colossal waves. Each time enough matter accumulates, boom, another explosion ignites, like a cosmic engine misfiring. But here's the catch, even this scenario shouldn't produce the sheer energy observed. The zombie star's repeated eruptions are 10 times brighter than any known stellar interaction, leaving scientists scrambling for alternatives. Another possibility. We might be seeing the birth of something entirely new, a magnetar in the making. These ultra-dense neutron stars, with magnetic fields a quadrillion times stronger than Earth's, could theoretically form in the wake of a supernova, their unimaginable energy briefly reigniting the blast. If true, the zombie star isn't just defying death, it's transforming into one of the universe's most exotic objects right before our eyes. Yet the most tantalizing question isn't how the star keeps exploding, it's why we've never seen anything like it before. Is this a freak one in a billion event, or are we just beginning to notice a hidden population of undead stars? Every new observation peels back another layer of the mystery, revealing a universe where even the most violent deaths might not be the end. The zombie star doesn't just challenge our models, it dares us to imagine a cosmos where stars don't die quietly, but rage against the dying of the light in ways we're only starting to comprehend. In the afterglow of the Big Bang, the cosmic microwave background that paints the sky in faint microwaves, there's a patch of cold so extreme it defies explanation. Stretching nearly 2 billion light-years across, the cosmic cold spot isn't just slightly cooler than its surroundings. It's a void within a void, a chilling anomaly where temperatures plummet far below what standard cosmology predicts. At first glance, it might seem like a statistical hiccup, a random fluctuation in the universe's baby pictures, but the odds of such a frigid blip appearing naturally. Less than 1 in 50, so what could carve such a cosmic freezer? One spine-tingling possibility is that we're staring at a scar from a collision with another universe. The multiverse theory, long relegated to the fringes of physics, suggests our cosmos might be one bubble in an infinite froth of universes, each with its own laws of physics. If a neighboring bubble once brushed against ours, the energy of that encounter could have left behind this cold spot, like a bruise on space-time itself. It's a radical idea, but the math holds up. Such a collision would have siphoned energy out of that region, leaving it unnaturally cold. Then there's the simpler explanation, an unfathomably vast void, a region of space so empty that light passing through it loses energy, stretching into longer, cooler wavelengths. But here's the catch: even the largest known voids don't match the cold spot scale or temperature drop. For this to be the culprit, we'd need a structure so colossal it shouldn't exist under our current models of cosmic structure formation. It's like finding a desert the size of a continent where maps showed only ocean. The cold spot's true nature might lie somewhere between these extremes. Some theorists propose exotic physics, like dark energy interacting with matter in ways we haven't yet imagined, creating localized pockets of accelerated expansion that cooled the region. Others wonder if it's a sign of cosmic texture's defects in spacetime left over from the universe's violent birth, like cracks in frozen lake. What makes this anomaly so gripping isn't just its mystery, it's the stakes. If the cold spot is evidence of a multiverse, it would be the first tangible clue that our universe isn't alone. If it's a void, it forces us to rethink how matter clumps on scales we thought we understood. And if it's neither, well, that might be the most exciting outcome of all, a sign that the cosmos still has surprises lurking in its oldest light. The cold spot doesn't just challenge our models. It invites us to dream bigger, to consider that the universe's greatest secrets might be written in the quietest, coldest corners of the sky. Imagine a substance that defies every rule of matter as we know it, something that isn't a particle, isn't a wave, but exists in a twilight zone between the two. This is the bizarre realm of unparticles, a theoretical form of matter so strange it could rewrite the textbooks of physics. Unlike the familiar protons, neutrons, and electrons that make up our world, unparticles don't play by the usual quantum rules. They don't have a fixed mass or energy. Instead, they exist in a sort of quantum fog, behaving more like a continuous field than discrete bits of matter. If proven real, they might hold the key to some of the universe's deepest mysteries, from the nature of dark energy to the missing pieces of particle physics. The idea of unparticles emerged in 2007 when physicist Howard Georgi proposed a radical thought experiment. What if there were forms of matter that didn't fit into the standard model, the framework that describes all known particles and forces? These hypothetical entities wouldn't interact like ordinary matter. Instead, they'd leave subtle fingerprints, tiny deviations in energy or gravitational effects that don't match predictions. Picture trying to measure the weight of a shadow or the temperature of a whisper. That's the level of elusiveness we're dealing with here. What makes unparticles so tantalizing isn't just their weirdness, it's their potential to explain the unexplainable. Take dark energy, the mysterious force accelerating the universe's expansion. If unparticles exist, they might permeate space itself, exerting a strange, uniform pressure that pushes galaxies apart. Or consider dark matter. Could it be that what we've been searching for isn't a particle at all, but something far more exotic? Unparticles could even help unravel anomalies in high-energy particle collisions, where certain events still defy the standard model's predictions. Yet the biggest challenge is proving they're real. Without mass or charge, unparticles would barely interact with normal matter, making them nearly impossible to detect directly. Scientists are hunting for indirect clues, subtle energy shifts in particle accelerators, irregularities in cosmic microwave background data, or even anomalies in the way gravity behaves over vast distances. It's like searching for a ghost by studying the breeze it leaves in its wake. The implications of discovering unparticles would be staggering. It wouldn't just fill gaps in our models, it would shatter the very foundations of how we define matter and energy. We might be standing on the brink of a revolution, one where the universe reveals itself to be far stranger, far more fluid than we ever dared to dream. And if unparticles remain forever theoretical, even that would be a revelation proof that some cosmic mysteries refuse to be neatly boxed, reminding us that the universe always keeps a few cards hidden up its sleeve. From ghostly galaxies to unexplained signals, these 22 cosmic anomalies aren't just curiosities, they're invitations. Each one whispers the same thrilling truth: the universe refuses to be boxed in by our assumptions. Whether it's the Great Attractor's invisible pull or the zombie star's defiant rebirth, these mysteries do more than baffle scientists. They redefine what's possible. Think about it. Every time we've cracked one cosmic riddle, another has taken its place, deeper and more perplexing than the last. That's not a flaw in science, it's the engine of discovery. Take a moment to sit with that. The wow signal lasted just 72 seconds, but it sparked decades of debate. The missing Baryon problem forced us to invent new ways of seeing the invisible. Even the humble moon, our closest neighbor, still guards secrets about its violent birth. These aren't dead ends, they're doorways. Every anomaly is a chance to ask better questions, to peel back another layer of reality. And the most exciting part, we're only scratching the surface. So which of these cosmic riddles left you spellbound? Was it the diamond planet, glittering in the void like a cosmic crown jewel? Or the Galactic Barrier, that invisible shield defying high-energy particles at the Milky Way's edge? Drop your thoughts in the comments. We're endlessly curious about what sparks your wonder. And if you're hungry for more mind-bending explorations, hit subscribe. The cosmos has a way of keeping us humble, and that's what makes the journey so exhilarating. Because here's the thing, the universe isn't just stranger than we imagine. It's stranger than we can imagine, and that's the real gift of these anomalies. They remind us that curiosity isn't just a trait, it's our compass, pointing toward horizons we've yet to dream of. So keep looking up, keep questioning, and above all, stay amazed. The next great cosmic revelation, it's out there waiting, and who knows, maybe you'll be the one to help uncover